In this video, we will be demonstrating the expansion of a perfect gas experiment, the TD1004V, for teaching the behaviour and expansion process of a perfect gas. This is one of various gases experiments from TecQuipment's thermodynamics range of teaching equipment for engineering. This helps you answer real-world thermodynamics questions like, why does the gas bottle on a gas heater develop condensation on the outside? This aerosol can goes cold when I spray out the contents. Why does this occur? The expansion of a perfect gas experiment approximates a perfect gas to make the study of thermodynamics of basic fluids and basic laws of thermodynamics easier to grasp, particularly the relationship between pressure, temperature, and volume. This easy-to-use experiment can be used to demonstrate air compression and expansion such as isothermal, isochoric, adiabatic, polytrophic, and contact internal energy processes. It can also be used to explore the thermodynamic knowledge relating to the first and second laws of thermodynamics, including the non-flow energy system equation, reversible and irreversible processes, and entropy. Specifically, you can learn about the non-flow energy equation, Clement and de Solmer's experiment, the behaviour of a perfect gas and its describing equations, adiabatic reversible process, isentropic expansion, constant volume process, constant internal energy process, and the polytrophic process. Let's take a look around the experiment. The entire setup consists of two main elements: the main apparatus with the vessels and gauges, and a separate control box that contains the pump and versatile data acquisition hardware. The main apparatus section is a standalone benchtop unit that consists of a frame that has two T-legs with adjustable feet, holding a steel panel where there are two different sized clear acrylic vessels. Each vessel has a fast response thermocouple and a pressure sensor and is connected to the mechanical pressure gauges mounted here and here to show the state of the pressure within the vessel when not connected to the control box. Both vessels are connected by this large bore pipe that allows the vessels to be isolated from each other and the surrounding atmosphere as required for the experiments. The vessels are also connected via a small bore pipe with a needle valve to accurately control the flow between the vessels. There's also a small ball valve at the bottom of each vessel to isolate the small bore pipe for some experiments. This vessel is for operating under pressure and the other for operating under vacuum, both pressurized by using this electrical air pump inside of the control panel. Although they're connected, which allows use together, the pressurized vessel and the vacuum vessel can also be studied independently as well. The main panel also features a third thermocouple on the end, which is key for some experiments where the temperature inside the vessels needs to be equal to the temperature outside. Now some more detail on the vacuum vessel, which can be used as either a vacuum or atmospheric tank. The top flange has both vacuum pressure and temperature sensors. Then the bottom flange features a vacuum port that can be connected to the vacuum port on the control box to allow you to extract the gas from the vessel. One thing you don't want is air entering it when it shouldn't, which is why it is self-sealing and will automatically seal when the pipe is removed. The pressure vessel, over here, is very much similar, albeit a little larger. It has the same sensors on the top flange and a pressure port on the bottom flange. Separate to the main experiment frame is a control box. This contains the VDAS hardware, a diaphragm pump, instrumentation for the sensors, plus digital multi-line display of pressures. The pump creates the pressurized gas, or vacuum. To do this, you connect the pipe here to the vessels using the clear hoses. You can refer back to the user guide for details on pressures. Some experiments require fast data acquisition, hence the separate data input area to the side here. Because of the speed of the data, it does not get displayed on the screen but goes straight to VDAS software for data capture and then analysis. Which brings me nicely on to talk more about the versatile data acquisition system VDAS. VDAS has both hardware and a software element. The hardware for this experiment is integrated within the control box. This control box is then connected to a computer with the free VDAS software installed. Safety is always paramount, which is why the flange on the pressure vessel holds a pressure release valve to prevent it becoming overpressurized. Another note on safety is that when the valves are opened, they can reach up to 100 decibels, which is why I'm wearing ear defenders here. So that pretty much finishes up our roundup on the expansion of a perfect gas experiment from TecQuipment. But you might also want to check out the Boyle's Law of Ideal Gases experiment or the Gay-Lussac's Law experiment on ideal gases. There are links for all of these experiments below. Don't forget to subscribe to the TecQuipment YouTube channel for more videos like this. And give this a thumbs up if you found it useful so others know it's worth watching. Thanks for watching.